All right. So in section 6, we're going to talk about function operations, and we're going to talk about composition of functions. Like I said, it's a lot of similarities to what you've done in Algebra 2. Okay. So basically, if you have two functions, f of x and g of x, you can take those functions, you can add them, you can subtract them, you can divide them, you can multiply them, and so on. If I were to add two functions, right, I would say f of x plus g of x. But there is a more concise notation. And all it does, it's not any more correct or mathy or whatever. All it does is just, it makes it more concise. You use less ink or space or whatever. Instead of saying f of x plus g of x, we condense it to f of g of x, right? I'm sorry, f plus g of x. So when you see this, all you do is take f, take g, and add them, okay? And so on and so forth. So here you're given f of x and g of x, and you have to do those operations for these. So a f plus g of x is equal to, you take your f of x, you add it to g of x, and that would be x squared plus x minus 4. Add like terms or combine like terms, okay? For b, now I want to do f minus g of x, x squared minus x. Now it's minus, right? So I have to put parentheses around the second one. And when I distribute, oh, thank you. When I distribute, it's x squared minus 2x minus 3x plus 4. X squared minus 5x plus 4. Okay. For the other one, we are multiplying the two functions. It's f times g of x. So we're just going to take f times g of x, and we're just going to do x squared minus 2x times 3x minus 4. And just multiply it out just like you did in Algebra 1, Algebra 2, all of that time, okay? And when you do that, what do we get here? 3x cubed minus 4x squared minus 6x squared plus 8x. And that is 3x cubed minus 10x squared plus 8x. Okay. Leave some space. We're going to go back and do domain in a little bit. Now for part D, we are dividing the two functions. F over g of x. It's going to be x squared minus 2x over 3x minus 4. Now, here's the issue. Do you factor anything out? Like, do you factor the x out on top? If you were to factor the x out on top, you would get x times x minus 2. Is that right? In doing that, does that take you any further in terms of canceling anything out? If it doesn't, then you can just leave it the way it is. But if you are able to cancel, then you have to go and do that. Okay, now let's go ahead and do domain. What's domain of the new function for part A? All real numbers. What about for B? All real numbers again. And C, same. What about D? It can't be 4/3. So it's negative infinity to 4/3 union 4/3 to infinity. No, if it's a closed bracket, then you're saying it can be 4/3. Yeah. It undoes what you are trying to say. Okay. Questions before I move on? Okay. Composition of functions. I know you've done this too. The composition of functions is when one function is put into another function. So so the resulting is a function that's made of another one, right? Like two nested functions. So composition of functions is given this notation, right? So in algebra 2, did you usually say f of g of x like this? Or, right, so f of g of x like that. All right, now, what happens when you have f of g of x is also a change in the domain. Did you guys talk about that at all in algebra 2? All right, so let's first find f of g of x and all that stuff, and then we'll go on and do everything else. So these are f of g of x like this. Okay. So if I want f of g of x, right, I want g to go into f. Is that right? So that's going to be, so g is going to go into f. All right? So that's going to be 2 times x plus 3 squared minus 1. So that's going to be 2 times x squared plus 6x plus 9 minus 1. 2x squared plus 12x plus 17. And then minus 1, so it's 17. All right. And then what's g of f of x? Now, f will go into g. So that's going to be 2x squared minus 1 plus 3. So that's 2x squared plus 2. Okay. Now, for the ones with the values in there, it's f of g of 2, right? If you think about it in the other notation, f of g of 2, I like to start with the inside here. What's g of 2? Because that's the inside. So g of 2 is 2 plus 3, 5. Then go out and then do f of 5, and that's 5 plus 3, 8. No, it's not. I don't know. F of 3, I'm sorry. 2 times 5 squared minus 1, 49. Right. You take what you got from 5, from G, and you put it in here. Okay? All right. I'm going to have you do B on your own, and then we're going to come back. I'm going to give you guys about 2 minutes to do B. I'll stop this for a minute. But see, now your f of x is the same as h of x. You can't do that. That's cheating.
Oh.
Yeah. Okay. This is not clear. Yeah. still, I mean, I guess it could work. Yeah. So there is not one, there are like different possibilities. Yeah. Yeah. So what was the one you said? Let's try it out.
X over root x, and then g of x squared minus 1.
I would take that. I would take that. Another possibility. Oh yes, that won't work. I'm sorry, it won't work. Sorry, nope, 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 nope. That won't work. I'm sorry. Okay, so here's one. F of x is root x over root x minus 1, and then g of x is x squared. I know, that's a so I will never give you one like this on a test. This is just like a fun example to do in class.
Wait. Why is it?
Because if you put x squared into here, you get x, and if you put x squared into here, you get x squared minus 1. All right, let's move on to this. So consider this function f of x equals 1 minus 1 over x. It says to describe the behavior of the function as x approaches 0. When you have something like this, this is called a limit, right? And oh, you know what? I'm going to add here from the positive side. So this is the limit as x approaches 0, okay? Of 1 minus 1 over x, and that's what we're looking for. So describe the behavior as x approaches 0. Whenever you're talking about x approaches anything, that's a limit. Describe the behavior means find the limit as x approaches 0 of this function. And so now we have this function. And so this is one where you need to sort of think about this. Okay? Here's my variable x, and I have 1 over x. The question is saying as x approaches 0. So as x is getting smaller and smaller to 0. Now, let's think about this for a minute. What happens to a fraction when the denominator gets smaller and smaller? Does it get bigger or smaller? It gets bigger. So think about this. If I have 1 pizza and I'm dividing it among like the whole class here, 21 people, how much is each going to get? Very small. But now let's say half the people leave, and now it's 1 pizza for 10 people. How much is each going to get? A little bit more. Now more people leave before the pizza gets here, and so now there are 5 people. 1 pizza per 5, even bigger, right? So as the denominator gets smaller, the fraction gets bigger and bigger and bigger. Okay? And so now, as it gets very, very small, 1 over like a million, 1 over like 0.0001 is going to be very, very big, like a million, right? So as the denominator gets small, the whole fraction gets very, very large, and it approaches infinity. Okay? But now, so this becomes an infinitely large number. But now, what's 1 minus an infinitely large number? A negatively large number. So what's 1 minus a million? Negative 999,000, right? So 1 minus infinity, or 1 minus an infinitely large number, is negative infinity. Now, so that's the answer, is negative infinity. Now, a word of caution. Infinity is an undefined number. We don't know how much infinity is. Don't ever get caught writing infinity in an expression. For example, don't ever write 1 minus infinity is negative infinity. That is points off. We never do like e over infinity. No. We never do infinity to square. Oh, no. Never, ever, ever. Okay? Never. Okay. Now. Yeah.
I don't understand how you use what denominator.
As x is approaching 0, it means it's getting very, very small, like diminishing to 0. And I know that if I have a fraction, as the denominator gets very, very small, the value gets very, very large.
Oh, so you know that's
Yeah, to 0, yeah. And it says x is approaching 0, right? X is approaching 0. Yeah. What happens as x approaches infinity? So the limit as x approaches infinity of 1 minus 1 over x. Now, as this gets very, very large, as x gets very, very large, what happens to 1 over a very large number? It's very, very small. So that approaches 0. So now I have 1 minus 0. I can write that equal to 1. Okay? Yeah. Mm-hmm. Uh-huh. Right. Well, it's 1 minus, yeah. Yes.
So as the x gets bigger,
Uh-huh.
then the value is smaller.
As the denominator gets bigger, the fraction gets smaller. So think about it. Think about it if you have 1 over 2. Right now we're going to increase the denominator. And then if you have 1 over 4, right? The denominator is now getting bigger and bigger. And now if you have 1 over 100, right? What's 1 over 2? 0.5. 1 over 4, 0.25. What's 1 over 100? 0.01. What's 1 over 1,000? 0.001, right? What's 1 over 10,000? Right. Yeah, so that fraction gets closer to 0, but you have 1 minus that. Yeah. Okay, so let's take a look at this one. This is similar to the one you did in the homework that we went over, right? Number, what is it, 65 was it? But now it's a little bit different. Same idea, but different strategy. Very, very big in calculus. Very, very big. Okay, I want f of g of 0. Remember, that's the same as f of 0 plus g of 0. Right? So now, f of 0, that's in the blue. What is that? -6, right? Okay, this is f of x. This function is f of x. So now I want f of 0. What is the value of y when x is 0? -6, right? Oh, but you can see that line, right? So this is f of 0 here. I mean, estimate. That's fine. Just estimate, right? Estimate to the closer one. Plus, what's g of 0? G of 0 is -6. So that's -12. Okay? -12. So now, I want f of g of -4. So remember, if I write it like this, right? G of -4, that's what I start with, right? What's g of -4? G of -4 is -4. So now, if I want f of negative 4? What's f of negative 4? Negative 4 again. Okay? Huh? Why is what negative 4? G? F. This is f. What's f when x is negative 4? What's the y? Negative 4. Okay? They're both at the same point. Okay, don't close your notes because I want to go over something else. Let's go back here for a minute. What if I wanted the behavior as x approaches 0 from the negative side? So now this is the limit as x approaches 0, but I want it to be from the negative side, right? So from the negative side, if I'm approaching that value, what are my, if I'm approaching 0, what are my values? It's negative 3, negative 2, negative 1, negative 0.1, negative 0.001, right? So what's 1 over negative 1? Negative 1, right? What's 1 over negative 0.1? Negative 10, right? So now the numbers are getting larger again, but negatives, right? So what's that gonna turn into? That's gonna be negative infinity, right? So now it's gonna be 1 minus negative infinity, which is positive infinity. You can't, because what's infinity? Because technically you shouldn't say it either. It's 1 minus an infinitely large number. That's the way you say it. Okay? 1 minus an infinitely large number is, you know, an infinitely large number that's negative and an infinitely large number that's positive. Okay. Okay, so today. All right, I will let you go.
Thank you.
Wednesday. You're welcome. Yes.
So for Alex, I didn't.
Yes.
Do I need to does it show that I can get a knowledge check?
I have to take a look at it. I haven't looked yet. Did you do it for this week?
Yes.
Okay, yeah. I haven't taken a look this morning.
Because like I just in case, I don't know, like they sent this like completion certificate that like I take a picture of.
I'll take a look, and then if there is an issue, then we can chat. Okay, but I'm sure it'll show up. Okay. Hey.
I just want to apologize.
Yeah, what's going on? So